Hello, welcome. In this lesson, I will do a quick introduction to engine. Our subjects are CFM engine introduction, engine thrust rating, and engine nameplate. Let's define the some terms. M1 trim. M1 trim is the difference of the real M1 needed for the real thrust provided, determined on the test cell only. The test cell measures the real produced thrust. Every engine is a bit different, so the M1 for each engine is different too for the same thrust. The M1 trim is there to make sure that, for example, at the 100% M1 seen in the cockpit, the exact same thrust is produced for each engine, while the real RPM not seen may be slightly different. The M1 trim must be programmed in the ID plug of the engine. Where is the ID plug of the engine? It's on the EEC, the brain of the engine. M1 trim number is just a number. It's not mean the 300% M1 or the 3 RPM. It's just a trim factor. It just tells us EEC to correct RPM at a certain amount. But how much we don't know. Another term, 1 libre is equals to 0.453. And other bump option term. Bump option is an option provided to achieve power levels greater than the normal takeoff levels within specific limitations. The bump rating does not influence the power levels which are at or below maximum continuous thrust. For example, an available bump, the redline values M1, N2, EGT remain identical to baseline rating. The CFMI is a 50-50 joint-owned company of the Sinagma France and the General Electric Aviation from the USA. First engine run-up, 1974. When it comes to defining of the engine, our engine produces electrical power, hydraulic power, and the pneumatic power, and much more. Our engine is high bypass ratio, dual rotor, and the turbofan engine. On the flip side, we have general engine data. Model of the engine weight, fan diameter, engine redline, M1 redline, N2 redline, bypass ratio, EGT start limits, and overall thrust rating is constant up to 30 centigrade degree, 27,000 RPM, 27,000 libre thrust rating. After 30 centigrade degree, our thrust rating decreases. Six thrust ratings: 19,000, 20,000, 22,000, 24,000, 26,000, and 27,000 libre thrust. A limited number of 6 engine thrust rating configurations are applicable to 737 model. The different engine thrust ratings are based upon the airplane weight and the elevator rudder control limits. These items shows on the engine nameplate: regulatory agency data, engine manufacturer data, and the engine performance data. The regulatory agency data blocks used depend upon where the engine was assembled. For the engine assembled by the General Electric, the two upper right blocks will be used. For the engine assembled by the SNEGMA, two upper left block will be used. The serial number will be filled every time. The first line of the 7 blocks will be filled at the assembly plant. The version of the engine will be in the config space. The second and the third blocks show the takeoff and maximum continuous thrusts in metric thrust ratings. The fourth and the fifth block shows the takeoff thrust and the maximum continuous thrust in pounds. The block 6 shows the M1 applied to that engine, and the last block for the service bulletin applied to this engine. The lower 3 blocks show the manufacturer data. The second block shows the manufacturer of the engine. For engine assembled by the General Electric, the block shows the General Electric Corporation. Engine assembled by the SNEGMA, the block shows the SNEGMA. And date. 6 additional rows are available to show the changes to engine. This permits 6 different thrust rating changes before you must replace the nameplate. The nameplates also shows the thrust rating history of the engine. Thanks for watching.